Okay, so we have a problem that says the man pulls up on the cord with a force of 80 newtons. Determine the angular acceleration, alpha, of the spool if there is no slipping at A. So at point A, we don't have any slipping. The spool has a mass of 60 kg and then a radius of gyration about its mass center G is 0.35 meters. There is a small, should do a small change in this force. There is a small error. First, let me erase this part. Okay. The problem is this force is actually passing through this point. Okay, that force is not, it's actually going this way. Okay. The angle is the same, 30 degrees, but the force is passing through this inner spool. Okay, let's first have a check on this experiment.
Right, kids.
You can see. Okay, so this is the case. So what it means is that, so we may not have, 1 minute. So in this case, we may not know for sure that will it rotate clockwise or counterclockwise. The best way to check it is that, so let me put it here. This is point A that we have here, that if the applied force, this is the applied force, in our case 80 newtons, it is, you see that the applied force, this is point B. If point B is behind point A, so we will have a clockwise rotation. And then spool, and then spool will move towards the puller. In that case, we will have the alpha this way, and then the acceleration is in that way. Okay, this is what it means. Okay, so with this in mind, let's solve the problem. Let's write the force balance first. Actually, free body diagram. Let's start with the free body diagram. Okay, and then for this free body diagram, we have point G, we have weight acting on it, we have normal force, we have the force here, that is F, with two components. It will have a horizontal component of Fx and then vertical component of f of y, and then the angle is 30 degrees. This is point G. And the last thing is that we have the frictional force F of F. Okay, what's the direction of the frictional force? Is it left or is it to right? Okay, to find the direction of the frictional force, it will need a little bit of imagination and mathematics together. The imagination comes, okay, let's start with the Okay, so with a little bit of mathematics. So we have a force here that pulls this thing, and that force has an arm of, this is the arm of that force about point G. Okay, and then we have the frictional force F of F, and then let's assume F of S is to the right, this way. And this F of F has an arm of this much. Okay, but you can see from here that F of F, this one, and then F. So now let's see. So F rotates spool in which direction? You can see the moment of F, actually not F, then so moment, the torque, let's say torque due to F, rotates spool in a counterclockwise direction, this way, about G. If you look for the frictional force in this way, then we have the torque due to F of F. Okay, we'll also rotate in counterclockwise direction about point G. So it means that both of them will rotate this one about point G in a counterclockwise direction. But the experiment we have just watched says the opposite. It says that, as we showed, it says that it moves this way, the clockwise direction. So it means that this is not possible, because in both of these cases we have a counterclockwise rotation. Okay, so F of F must be to the left. This way, so F of F will cause a clockwise rotation, and then the F will cause a counterclockwise rotation. A result is that the clockwise rotation. Okay, that's the result of the direction of the frictional force. Okay, so now let's continue in the next recording.